Do you suffer from dull, dangerous drill bits? Do you feel compelled to protect the good drill bits from your spouse and coworkers? Introducing Drill Bit Sharpening, our fun, step-by-step program that's so simple, anyone can do it. We guarantee you'll have your drill bits sharpened in no time. Limited time offer, some restrictions apply, void where prohibited, guarantee is not a guarantee. We are experiencing a plague of flies on a biblical scale. I've never seen anything like it. In my last video, I talked about drill bits and I mentioned hand sharpening, but I didn't actually show how I do it, which generated a lot of comments. So here we go. Prepare to learn more than you ever wanted to know about drill bit sharpening. It's really not that hard. All you need is your eyes and a decent bench grinder. You want to see just how accurate your eyes are? Check this out. I'm about a meter away from the camera lens. Am I looking at your right eye or your left eye? Right eye or left eye? It turns out from this distance, almost everyone can tell the difference. That means that your eyes can see a 2-degree difference in my eyes. That's about a half a millimeter, 20 thousandths difference in the location of my iris that you can see from more than an arm's length away. From a close distance, your eyes literally have hair-splitting accuracy. There are more kinds of drill bits and drill bit sharpening styles than you can possibly imagine. But the two most common for general metalworking are the 118-degree chisel point and the 135-degree split point. Come on, flies. The 118-degree tip is probably the most common. They're cheaper and a little bit easier to sharpen. They work well in soft materials, including mild steel. They tend to hold size well, meaning that they drill the diameter that they're supposed to drill. The only real disadvantage is this chisel tip. It's not really a cutting edge. It's more of a forming edge. It actually has to push the material out of the way, out towards the cutting edges. And it can take a lot of force. If you're using a drill press or a mag drill where you've got some leverage, that's not an issue. If you're using small drills, it's not a big deal. But if you're trying to use a hand drill like this, the chisel tip can really add to the struggle. The 135-degree tip is a little more complicated. The chisel point has been split by an extra grinding operation, and that makes this 4-sided cutting edge. That reduces the thrust by a lot, up to 50%. It also helps keep the drill from wanting to walk or wander when you start the hole, especially if you haven't spot drilled or center punched. So they tend to hold location well, but they're more likely than the chisel tip to drill oversize. What drills can you sharpen? Well, there's really no limit, but I would say anything above about 5 millimeters, about 3/16 of an inch, is worth sharpening. Smaller than that, and your returns diminish pretty quickly. Also, don't waste your time trying to sharpen crappy, no-name drills. We all have them. They're handy for certain things, but no amount of sharpening is going to make up for crummy steel or a crappy heat treatment. Don't even waste your time. Drill bits do wear on the outside, and there's not much you can do about that. You can try to grind down past where they're worn, but eventually a drill bit wears out and there's nothing you can do to make it drill the diameter that it's supposed to drill. Some drill bits are easier to sharpen than others. Usually the bigger the drill bit, the easier it is. And then this section here between the flutes is called the web. And in my opinion, the thinner the web, the easier it is to sharpen. And kind of the geometry, the angle, the shape of the flutes varies between drill manufacturers. It even varies between different sizes of drills in the same manufacturer. There really is no standard. Different styles work for different materials, and a lot of times the only difference between different series of drills is just the shape of the flute. I probably wouldn't use hand sharpened drills for production work or anything where you expect high performance or high accuracy. For manual machining or just drilling by hand, it's perfectly fine. Come on, fly. What tools do you need? Well, there's all kinds of gadgets for drill sharpening. Everything from $5 attachments for your cordless drill to $30,000 drill sharpening robots. I'm sure everybody's heard of the Drill Doctor. Those might be awesome. I have no idea. I've never used one. This is my drill sharpener. It's just an old 8-inch bench grinder. Nothing special. This is an 80 grit wheel, which is on the finer side. You can use a coarser wheel. You just won't get as nice of a surface finish. And you have to be careful that you don't take off too much material. You do need a way to dress the wheel. You want it to be nice and flat and to have as sharp and crisp of a corner as possible. That'll be important when we do point splitting. I use one of these rotary wheel dressers. Works pretty well. You can get those at any hardware store. I also have one of these dressing sticks. This is a Norbide made by Norton. These are more for dressing radiuses, but they do work for dressing the face of the wheel as well. Most bench grinding wheels are too soft to really hold a sharp edge, so do the best you can. If you're going to do a lot of point splitting on small diameter drills, you're probably going to do a lot of dressing. And you get what you pay for when it comes to grinding wheels. This is a carborundum, which is a brand name, not a material. Other good wheels are made by Norton, Radiac, Camel. They're available from industrial supply companies like MSC or McMaster-Carr. Or if you're outside the US, I'm sure there's an option where you live. These are drill point. Come on, fly. These are drill point gauges. I've got a bunch of them. And they're all pretty much useless as far as I'm concerned. So they help you get the right angle on the tip of the drill, but they don't solve the biggest problem, especially when you're hand sharpening, which is getting the lips even. You can have the right angle and still not have a good point. So I designed these gauges, patent pending. The drill bit fits into the V. You slide it up into the gauge, and you can easily see if your angle is right, and more importantly, you can see if the lips are ground evenly. There's one for 118 and one for 135. They work up to about 1.25 inches, about 30 millimeters in diameter. I'll put the models on my Patreon page. You guys can go download them and print them yourselves. They print super easy without supports. Maybe I'll put the drill bit models up there too. You might be thinking that the hot drill bit off the grinder is going to melt the plastic. And you're not wrong, but that's actually a feature, not a fault. If you get the drill bit hot enough to melt the plastic, you're going to be affecting the heat treatment. All right, talk. How do we actually sharpen a drill bit? This is the first drill we're going to sharpen. It's a 135 degree split point cobalt drill. It's not in too bad a shape, but the lips are kind of chewed up here towards the center. And this is a good time to sharpen it. The longer you wait, the worse they get, the harder it is to bring them back. Let's pretend that this plywood is a grinding wheel, and it has imaginary horizontal scribe lines. The first thing we want to do is grind the actual cutting edge, and it's on a compound angle. So if we imagine that there's a plane that runs through the cutting edge and tangent to this surface, that would be the relief angle. We want to line up that plane with the face of the grinding wheel. And then we want to take the actual cutting edge and line it up with our imaginary horizontal scribe lines. And we're just going to feed it straight into the wheel. And I like to start shallow and then rotate the bit down. And when I start to see sparks here, that means the actual cutting edge is in contact with the wheel. There's material being removed from the actual cutting edge. And we don't want to go much further because then we'll be too shallow on our relief angle. So we're just going to follow the factory angle, kind of lock it in, and then I like to feed across the wheel so I don't dig a groove in the middle of the wheel. Work our way along like this, flip it 180 degrees, do the same thing on the other side. Now we have our cutting edge, but behind it we have a flat plane. That's called a facet grind. And it probably actually would cut like that, but it would be better to have this spiral shaped relief. That's called a conical grind. And to get that requires kind of a complex move. You sort of have to start here and kind of twist down. I like to use the rest and kind of just roll it through. And you want to end up with your cutting edge horizontal, and then you stop when you see the sparks right at the cutting edge, because you don't want to actually want to grind the cutting edge any further. We've already established that. We'd like to just kind of leave it alone. We're just trying to relieve the back side. So if you extrapolate out this relief surface, it actually creates a cone. That's why it's called a conical grind. And if you kind of imagine the center point of that cone, that's basically the point you want to rotate the drill bit through. It's kind of a complicated motion, but with a little bit of practice, you can get it pretty close. It doesn't have to be perfect. Typically it's around 12 degrees, and it gets steeper as the drill bits get smaller in diameter. If it's too steep, the cutting edge won't be as strong because there's not as much material behind it. It wants to chip out. If it's too shallow, the backside wants to rub, and then it won't cut freely. For hand drilling, I mean, it doesn't really make that much difference. Just you need to have some relief. So we're rolling it through, trying to meet up with the cutting edge, but not actually take down the cutting edge. You really want to take your time with this step. It's very easy to grind too much relief or grind into the cutting edge and undo the work that you just did. So if we were grinding a chisel point, we'd be done. But for this 135 degree drill, we need to split the point. And it's another compound angle. So you come over here to the side of your grinding wheel. And I like to start with the center point off the wheel and kind of get my angle established. I'm grinding, trying to follow the factory angle. You may have to fudge it a little bit. And then once you get it kind of where you want it, you can move the drill bit over towards the center. It's not perfect. The relief angle is a little bit too shallow, but overall, that's a pretty good grind. Hand grinding the split point is always going to be a compromise. You're never going to get that sharp inside corner like the factory grind. They're using diamond or CBN wheels with a perfectly sharp edge. You just do the best you can. You kind of want to have your split points in a line across the drill. You don't want one ahead or behind the other. And you actually don't want to take out the entire chisel point. You want to leave a little bit there. That helps the drill stay centered, and it helps it stay straight as it's drilling. Let's try something a little more challenging. This drill bit has obviously seen better days. I'm actually just going to cut it off, and we'll start over from scratch. We're doing a lot of grinding, which means a lot of heat. Dunking it in water is just fine, as long as you don't get it too hot. High-speed steel is extremely shock resistant. Really, the process here is exactly the same, except we don't have the benefit of following the original factory grind. This drill bit has a thin web, which makes it easy to sharpen, but that's also why it snapped off catastrophically. There's always a balance. This one's not looking too good either. I think we'll do the same thing. We'll just chop off the end and start over from scratch. This drill bit has a much thicker web, which makes it a lot tougher, but it also makes it tougher to sharpen. This isn't real time. I did edit a little bit, but it's pretty close. Once you get comfortable, it really doesn't take long to hand sharpen a drill bit. Again, they're not perfect. I'm not a machine, but I'm pretty happy with the results. Let's test. This is a piece of mystery steel. I think it's hot rolled. I don't know. Let's see what happens. We're looking for 2 chips. That'll tell us that we got the lips ground evenly. Seems to be doing okay. This is some pretty nasty gummy steel. We got a little bit of damage. This is some nasty steel. I thought it was hot rolled mild steel. I don't know, maybe it's a piece of tool steel. You never know. There we go. Seems fine to me. That's a pretty good sized hole to hand drill without a pilot hole. Good enough for me.
So many moths. Are you alive? There's so many moths. So many.
What can we help you with?
I was just checking to make sure you were alive.
I am alive. All right, what is it, 11 o'clock, midnight?
It's almost 11.
I'll be done soon.
Okay, good.
Come on, flies. That's it. It's really not that difficult, but it does take some practice and some patience, and you're gonna struggle, but that's okay. These drill bits are long, they've got a lot of flutes, you can grind them all the way down to the shank. Leave me a comment and let me know what you think about this kind of video, this sort of didactish, pseudo-instructional video. It's a ton of work to put these together, and I'm not gonna keep doing it if people aren't gonna watch them. But if it's what you wanna see, there are some tidbits of knowledge rolling around inside my head, and hopefully I've done a decent job of articulating them. What I don't want is for it to be like when I would cook with my mom, and she would have a recipe that I would follow along, and then, you know, the whole time she's just doing things that are not listed on the recipe and not saying anything about it. And when I would ask her, she would say, well, that's how I always do it. You know, tribal knowledge, it's difficult to convey. You really almost need a coach. That's the best way to learn it. Anyway, thanks for watching.
I can't reach it.
We're about 20 minutes into this project, trying to get the bird out of the shop. It is not very smart.
How about we just leave it up there? It's a smart bird because it doesn't want to go outside.
I think you just have a new pet.
I guess so. Come on, bird. Max. Wish you had wings, pup. All right, we finished our 30-minute bird extraction.
Oh my goodness, so ridiculous.
It's the first time I've seen a drone spraying in our area. Pretty cool. Not quite as dramatic as the helicopter. Needs a voice like Mr. Handy. Oh, there's a crop duster in the background. That's pretty cool.